Let's solve homework exercise number 19 from section 11.3. It states a group of campers is going to occupy 4 campsites at the campground. There are a total of 15 campsites from which to choose. How many ways can the campsites be chosen? Again, at this point, we're just choosing 4 different campsites, and whatever 4 are chosen, any order, it's going to be the same 4 campsites, right? There's no order involving. So order does not matter, okay? And when order does not matter, it's solved with a combination, right? All right, combination. So again, so we're going to use the combination, and we've got a total of 15, and we're selecting 4. Okay, so working it out, we would have 15 factorial divided by 15 minus 4 factorial times 4 factorial, right? So it would be 15 times 14 times 13 times 12 times 11 factorial. 15 minus 4 is 11 factorial. So these 11 factorials, 11 down to 11 times 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, all cancel. But we still have the 4 factorial, which is 4 times 3 times 2 times 1. So our answer is what? 15 times 14 times 13 times 12, and then divide by the quantity 4 times 3 times 2 times 1. Okay, applying the combination formula. So if we do that, those multiplications, using our calculator, 15 times 14 times 13 times 12, and then divided by 4 factorial, which was 4 times 3 times 2 times 1. And we get an answer of 1,365. Okay, and again, remember, combinations is on your calculator, so you could simply do this by putting in the total number, 15, and then hitting the math key, and then going over 3 times to highlight PRB, NCR, go down 2 to highlight NCR, hit enter. There's your combination, so you know you're using the combination formula, and you're selecting the number you're selecting, putting in next, which in this case is 4, hit enter, and I'll get your answer of 1,365. All right, very good. Let's look at number 20. A comedian knows 4 jokes on a given night. If the order in which these jokes are told makes a difference on how they receive, how many different 4 joke routines are there? Okay, so again, he's got 4, and we're using all 4, and the order in which they're told makes a difference. So order matters. Okay, so when order matters, it's a what? Permutation, right? So it's a permutation, and he's got 4 jokes, and he's telling all 4, so it's 4P4. Okay, so 4P4, again, you can do on your calculator. You got the permutation, so you put in the total number 4 you're working with, and then go to math, go over 3 to probability. NPR is number 2, so you can highlight number 2 or him simply at number 2, and we're telling all 4 jokes. Whoa, answer, sorry. Didn't put in 4. Let's try that again. 4, math, PRB, permutation is number 2, and 4, now I think we got a, yeah, 4P4 is 24. All right, very good. Let's look at homework exercise number 21. A comedian knows 8 jokes. One joke is old, 1 joke is new. The other jokes are somewhere between. If the order of these jokes are told makes a difference in terms of how they are received, how many ways can they be delivered if the old joke is first and the new joke is last. So this is the old, and then we have 1, 2, 3, 4, 5, 6 jokes, and then we have the new joke is last, right? Now, because we have a total of 8 jokes, right? So I made 1, 2, 3, 4, 5, 6, 7, 8 with the old first and the new second. Now, the old joke must be told first, so there's only 1 choice for the first joke. It's that old one. Similar, the new joke was told last. There is only 1 choice for the new joke, okay? But now, after we've got a total of 8 jokes, so we've used 2, so we've got 6 jokes left, right? So now, the second one, we've got what? 6 choices, right? And then we use up 1 joke, and then we got 5 choices, and then we got down to 4, 3, 2, and 1, okay? So our answer is 6 times 5 times 4 times 3 times 2 times 1, and the other times 1 doesn't have an effect. Or another way, this is really using the fundamental counting principle, or another way of you thinking of it is, after you get the old and the new, there's only one way of doing it. You've got the order of the 6 other jokes. Order matters, so it's a permutation, and you're going to use all 6, so it's 6p6. And 6p6 is going to be 6 factorial divided by 0 factorial. 0 factorial is 1, and again, 6 factorial is your 6 times 5 times 4 times 3 times 2 times 1. Okay, so really here, you can solve this with the fundamental counting principle or the permutation formula. Either way, you can do it, okay? So whatever, if we do it on our calculator with the permutation, 6, math, and then go over to highlight probability, 3 over, and then permutation is number 2, and we're selecting all 6 jokes after we use the first and the last with the old and new, and we get 720. Okay? So kind of a neat problem there. Makes you think a little bit. All right, number 22. A 4/45 lottery involves 4 numbers from a total of 1 through 45. 3 27s, 3 from a total of 27. The order in which the numbers are chosen does not matter, so we're doing a what? A combination, right? Which lottery is easier to win? Well, we're going to go ahead and see how many possibilities there are, right? That's what it depends on. The smaller number of possibilities is the easier one to win. So a 4/45 is, again, order does not matter, they're both combinations. So that would be a total of 45 numbers we're choosing 4. So we'll do that on our calculator. The other one is 327. So we got 27 total numbers and we're choosing 3. So we'll do both of those, okay? So both of those is a combination. We'll do those on our calculator. Get the answer for both. So we got 45C4 for the first one, 45 math, and then over 3 with your arrow to probability. NCR is number 3, and we're selecting 4 with this lottery, right? So this lottery is 148,995. The 27C3, okay, so we got a total of 27 math over to PRB using the right arrow 3 times. And then NCR is number 3. In this case, we're choosing 3 numbers. Okay, we only get 2,925. So definitely the 327 lottery is easier to win because there are only what? 2,925, 2,925 possibilities compared to the possibilities for the 4/45 lottery is 148,995. A lot more possibilities, so definitely the 327 is a lot easier to win. Okay, so we did each one with the combination. All right, this concludes all of the homework exercises for section 11.3. This is your math teacher, Dr. Swears. I hope you found this video helpful in solving these problems. If you still need more help, send me an email in the inbox through the Canvas course, and I will respond as quickly as I can. Again, thank you for watching these videos, and I hope you found them very helpful.